determination of the scope of the project. Now, what we want to do for this loan institution, the business environment, so we are collecting all this data about the investor, about the loan center, about the types of loans given, about the steps of loans which are going to go through till the approval, till the financing, about the customer's credit rating and all that. So we need to now know these are the 3 queries which we want to answer for this loan institution. Query 1 is how much loan amount is outstanding per loan center. I just want to know, and that is something which I have to now know whether it's going to be per day, per week, per quarter, per year, or what. So that's the time series. Query 2, how much loan amount is outstanding by loan product. The loan product means, let's say, giving a mortgage for buying a house is a loan product. Providing a mortgage, providing a loan to take care of your accounts payable for a business. So that's a loan product. Then query number 3, how much loan amount is outstanding by time, broken out by quarter and month. So these are the 3 queries which our people, our management, or whoever your users or sponsors are, would like to have answers on. So these are what we want to answer with our performance dashboard. Okay. Now, so for this loan institution, as we said, scope creep, once these 3 queries are answered, new queries will pop up, because now when they see, oh, you can tell me about the loan center. Now, that's good, but can you tell me for the loan center, for these loan officers, for the loan center, because maybe I have heard just somehow that some of these loan officers are doing better than some others. So I want to have some facts, numbers, not just some hearsay, but I want to go with the actual numbers. So can you now, for this loan center, not only give me the outstanding loans for this last quarter, but also give me outstanding loan for the last quarter for this loan center per loan center officer. So those new queries will come up. What does that mean? That means whatever I'm going to design for my dashboard, it should not be tailored only for these 3 queries. It should be done such that I have the flexibility of answering many types of questions as long as I have the data for it. That means my design has to be flexible enough that I can roll up into summaries, and when looked at the summaries, I may want to drill down to the detailed data and then come up with new summaries. Okay, so that's very, very important, because you should not design anything for only these requirements which are posed at the start of the project. Because as we said, when they see something, then new questions come up and they need to be answered, and without having to go through big hoops, you should be able to answer. And that's what the basic design concept is. As long as you have data, you should be able to answer the questions. The detailed data should be there, of course, and that data should be accessible from the, as we said, we have 3 levels. The data is sitting here at the bottom. That is our database. And remember, one of the things, it's at the bottom. Dirt collects at the bottom. That means cleaner the data you are going to store, better off you are going to be. Now, do you have to clean all the umpteen terabytes of data? You will never get done. That means you have to know which data matters the most, and that has to be cleaned. Okay. The next level is our OLAP, where we analyze, we prepare summaries, and the 3rd level is where we present it in the performance dashboard. So that means this is going to be not just a plain dashboard, but it's going to be a performance dashboard. That means we have to understand the difference between a plain dashboard and a performance dashboard, and that's going to be our second unit. So that's the unit number 2. Dashboard types, plain and performance dashboards. So it's the same raw data used for these different types of performance dashboards, and with that we look at the differences between the plain dashboard and the performance dashboard in unit number 2. Of course, we need to know how all this data is interrelated, and for that we need to know about the database architecture, and that's our third unit, which talks about database architecture. So do we need to know how the different raw data is interrelated? Of course, because if that data is there will be questions that will be asked, because we are not talking about this manufactured car with all the windshield wipers and so on. We are not comparing that with the pizza. They are not interrelated, so that data is not going to be in your database. The data which is in your database or databases has to do with your business. You are not, let's say in this case, in a pizza business. You are in car manufacturing business, or you are in a banking business. Then that data is all interrelated, and for that, that's our raw data. So how do we design our database so that we can answer all these questions? Now, I have collected all this data. How am I going to do this now? This is my computer here. This is my database software. I have to communicate with that database management system software. There is a language. How I communicate with the DBMS so that the database management system, otherwise it will just keep on looking at you, and what? You have data, zillions of megabytes or terabytes of data. Now we have to say it's all interrelated, but I have to communicate to the database management system, whether it's Oracle or whether it's Sybase or whether it's DB2 or whichever database management system you're using. I have to communicate with the database management system. That means there are different languages. One is what? Data definition language, data manipulation language. That means now I'm going to manipulate the data. That means I should be able to read the data. I should be able to create the database records. I should be able to read the database records. I should be able to replace the database records. I should be able to update the database records, and I should be able to delete the database records. So these are really 4 major operations. CRUD, CRUD. Create, read and replace, update and delete. So, and that is data manipulation language. And of course, there are multiple different languages which are used. I mean, there is Java and whatnot, all the kinds of languages, basic, starting with basic all the way till you can go to whatever. I mean, sometimes I have questions about these nomenclatures and all that. It's like something said C++, okay, C++, is there C minus minus? I mean, why C++? But if you put 3-4 letters together in this business, 3-4 letters put together, there is some kind of acronym out there. Or even now 2 letters, 2-3-4 letters put together, there is some acronym out there. So now, to communicate with the database management system, it's data definition language, data manipulation language, and for that, we are going to use for this open software something called structured query language. Again, I have an issue with the term structured query language because it's not necessarily structured, but that's besides the point. So now, this is what we need to understand about database architecture. Going from raw data, we are communicating, because what is a performance dashboard? Its performance dashboard is really for communicating with the people who are going to make decisions. So information technology, in a nutshell, is communication. That's what it is. You have data, you want to communicate with that data, whoever the different audiences are. That's what IT is about, communicate. Unfortunately, many IT professionals do not like to communicate with people. They prefer to communicate with the machines, but they don't like to communicate with people. And unfortunately, this is what is a big problem for a number of IT professionals. But again, that's besides the point. We are not going to cover that in these units. So this is our unit number 3 about database architecture. Okay, now we did that. For performance dashboard, we have to have various measures, matrix, key performance indicators. Now, how do we decide what is the key performance indicator? How do we measure it? What are the different matrices? Why are there so many names? Measures, matrix, key performance indicators, and so on. That means we have to understand how to do that, and that is going to be something which will be our next unit. But in this world, this is your DDL, home loan mortgage, about house condominium, refinancing of home, and so on. So that's our relation 1. That's our we are going through the database architecture, which we said about data definition language. Investor from I, let's say investor I going from 1 to N. Okay, so investor 1, investor 2, investor 3, up to whatever investor N. So we need to have all the information about investor name, contact information, financial worth at present, and so on. So then we need to have information about loan center. Where is it located? What kind of clientele does it get? What kind of demography is there? And so on. That's about the loan center. Then we have the time dimension, which is the year, quarter, month, week, day. Sometimes we may have to have for day, and not even for day, but maybe for a minute. You're talking about Wall Street. In that case, it's every single second counts. So for performance of the stock market or for a specific stock of a company, you have to go very minute time frame. Whereas number of employees in your company, you don't need to go to the minute per second, but per week or per month, you might be just fine. So it depends on how much granularity you have to have for your data, depends on your business. So that's the time factor. Then our customer, I mean, you have to have customers in order to have a business. Let's face it, no matter which business it is, you have to have customers. So this is our customer who is taking a loan because the bank gets money from investors. In a way, the customers of the bank are also investors because they deposit money in the bank uses that money to give out loans. If the bank is smart enough, it makes good loans. If the bank is stupid enough, it makes bad loans. And we have seen this happen in the past few years. If you become too greedy, then you are going to go down faster. Okay, and that has happened. Okay, so those are the loan customers. Then, so also for every loan, there are different steps which the loan officers have to go through. Setting up of the loan. Somebody walks into the branch, the loan center, wants to have that. So our first, which is the stage 1, all the way up to the funding provided to the customer. So there are various steps, and all along, as long as you're following those steps, keeping your common sense, you're fine. You see, 5 years ago, I was on a panel, and next to me was sitting somebody who was a loan officer at a bank. Let's not name the bank because the bank is acquired. I mean, I knew that 5 years ago that was going to happen, because I said, how is your performance measured? The person said, we measure it based on how many loans we make. So how many loans do we make? Based on that, the